Morning, we are doing the pulse amplitude modulation experiment using the Bughaw Electronics Solutions and Technologies. Now, the objective is to get familiar with the pulse amplitude modulation. So, first instruction in the main menu, press 2 to choose pulse amplitude modulation. We did it already. Press 1 to choose pump. Okay. And let's observe. Kindly read ninyo.
Observe the amplitude of the pulse with respect to the input. Pump transmits data by sampling the input signal. By sampling, the output gets a value of the input periodically. The rate at which it gets a value is called sampling frequency. Sampling frequency is the reciprocal of the period. From the display of the pump signal, approximate the default sampling frequency by first getting the period of the amount of time before the output samples another input. Zoom in or out to get a better estimation. Graph the input and the pump output in the table below, labeled Case 1. The user can opt to pause the display by pressing spacebar. Make sure that the parameters are in their default values or press caps lock to ensure that the input and pump output are at default.
Caps lock? You press it already?
I just pressed pause so I could take a picture of the case one.
Caps lock.
Now it says press caps lock.
And then, next.
Next, press Q 3 times. This decreases the pump sampling frequency.
Okay.
1, 2, 3.
Okay. You have there the period, 80 milliseconds.
Graph the input and pump output in the table below, labeled Case 2A. Press W 6 times or press caps lock and press W 3 times. This increases the pump sampling frequency.
Okay, press W.
6 times.
Yeah. After pressing W 6 times, this is the result.
And then,
You press spacebar to
Pause.
pause. Yes. Okay, continue.
graph the input and pump output in the table below, labeled Case 2B.
Case 2. Next page. Okay, this is where you're going to graph. Okay. Next.
Press caps lock and press A 3 times.
Okay, caps lock.
Caps lock.
Default. A 3 times.
This increases the input frequency.
Yeah, the input frequency increased.
Okay, next.
Then grab the input and pump output in the table below, labeled Case 3A.
Okay, pause for case 3A. Okay, continue.
Press S 6 times or press caps lock and press S 3 times. This decreases the input frequency.
Okay, caps lock. And then S 3 times.
Okay. Let's play first.
S 3 times.
Let's play the caps lock S 3 times. 1, 2, 3. Yes.
Okay. Continue.
Next. Grab the input and pump output in the table below, labeled case 3B.
Okay, you may pause it. It's paused already.
Yeah, passed already.
Okay, na. So that's the last.
Says
Next.
observe the different graphs. Case 1 has the default settings. Case 2A and case 2B have constant input frequency while changing the sampling frequency. Case 3A and 3B have changing input frequency while having a constant sampling frequency. Based on the observations, relate the input frequency and the palm sampling frequency to the palm output. You have to compare the cases to each other and put an answer. And when the output samples the input, the output holds the value for some finite time. This time is called aperture time, which is also the time width of the pulse. From the display of the palm signal, approximate the default aperture time, zoom in or zoom out to get a better estimation.
Okay, you try to zoom in and out. So that's the last.
Yeah, that's the last.
Okay, thank you. And you may now proceed with
Successful.
the next experiment.